We have another question that is a bit similar to the first one we solved, but there is a twist here. This one has 5 raised to the power 2x plus 1 minus 26 5x plus 5 all equal to 0. So even though it looks almost the same with the first one we solved, there is a slight difference that we must observe for us to be able to solve this and arrive at the appropriate values. Okay, the first thing we need to do is to analyze this. We quickly write down solution. Okay, our solution begins at this point. We take this and then simplify it so that we can apply it along line by the time we start solving. So we have x is going to be squared. Look at this. I've taken it out. Times 5 is raised to the power 1. That's the meaning of this one you are seeing. Is an indicial concept. If you have learned the concept of indexes, you will understand what has happened here. Then we move on to the next one. We retain it the way it is. 26 bracket open 5 exponential x bracket close plus 5 all equal to 0. Okay? What do we do next? Look at this. Okay? It becomes something to take care of. We are going to set 5x to any letter of our choice. So far, we can substitute accordingly and arrive at the appropriate value. So we set 5 exponential x. Maybe this time around we are going to use a p. Okay? Let's p represent 5 exponential x. It means wherever we have 5 exponential x, we substitute with p. That's what it means. Okay, the first one is 5 exponential x. So we have p, right? Brackets squared, right? And then we have times, because 5 raised to the power 1 is still 5. We maintain this minus 26, right? We have 5 exponential x, which means we are going to substitute with p. It becomes p, right? Plus 5 all equal to 0. Take note. That's how to solve this. Okay? So move on again to clear out all things and then generate a quadratic equation. And that becomes this squared times this is going to give us 5p squared, right? Okay? That is it. Maybe my p is written as a subscript instead as a letter standing on it on 5p squared. Good. So we have minus 26p, right? And then finally we have plus 5 all equal to 0. Look at this. Look at this. We have finally generated a quadratic equation of this range. It is time for us to check which of the quadratic formula or methods will be appropriate in solving this. So if you have watched up to this moment and have found value in this, subscribe. Give me some thumbs up and then share with friends, networks and students. Don't forget to put on the bell button for constant notification so that each time stuff like this are uploaded, you'll be notified. Thank you once again, my returning subscribers and my new subscribers. Let's continue from there. So we look at this. We apply factorization method because it's one of the easiest methods of solving a quadratic equation or to all quadratic equations, so to say. So what do we do here? We can factor further. We can factor this further into 5p bracket open first of all minus 1, bracket close. Also, P, we have plus here, right? Watch out. We have plus here. What do? Minus 5, bracket close, all equal to 0. So look at this. We have factored this into this. It means that this is the factorization method approach of solving this quadratic equation. So take note. By the time we say 5p times p is going to give us this, and we move again, 5p times 5 is going to give us 25, and then rest of it. So it's going to be okay by the time we simplify further. What does this mean? We continue by saying that 5p minus 1 can be equated to 0. Then the second bracket is p minus 5 is also equal to 0. This is interesting, isn't it? Good. So let's move on. Let's talk. Okay, so we continue from there. The first one, we can call this equation 1, we can call this equation 2. Doesn't really matter anyway. So the first thing we need to do, having identified this, when I say 5p is equal to 1, okay? Therefore, p here is equal to 1 all over 5. We take note of this, okay? We move forward again. We move further to simplify the next one, which is p. It becomes p is equal to 5, right? That means the value of p is just 5. But that's not all. There are things we need to do, right? We have successfully found this, and this is absolutely okay. But we need to find the value of x in the equation given. That's what we need to find. And to do that, we need to consider certain things. We go back again, 5x, because remember, we simplify into this to enable us find these values. Okay? Now we have done that. The first one we're going to check is this. Okay? The value is this. So we have 5x, 5 exponential x is equal to 1 all over, where is my chalk? Is equal to 1 all over 5. 1 over 5. Okay? That's the first one. I'm using this. I'm taking care of this now. I want to find the value of x at this point. So look at it. We can as well write 5 exponential x is equal to change this. This or 5 minus 1 is still the same thing. Nothing has changed here. So we can put this as 5 minus raised to the power minus 1 in this shall rule. So by the time we cancel 5 and 5, we now have that x is equal to minus 1. Solved. So we have found the value of the first value of x. Now let's go on and find the first value of x, the second value of x. This one is the first value of x, while this one, by the time we apply this, will give us the second value of x. Now we've done that. The second value of x, we continue again, 5 exponential x is equal to 5, because that's the second value here, okay? Which represents p, yes. But we are no longer concerned with p because we have found the value of the p as 1 over 5 and 5 respectively. So what we're doing here no longer concerns p, but the value of p. So what do? Look at this. If we have this, it means that 5 has a power 1 unit. Okay, there is a unity here, 1. It means that x is equal to just 1. Because by the time we cancel this, remember there is 1 here, it will cancel all this, x is remain, okay? And then we have x is equal to 1. So this is the answer. Therefore, x is equal to minus 1 or 1. This is what should be our final answer, and the values of x according to this equation given. Thank you so much for watching up to this moment. Thank you for your patience. I encourage you to subscribe, okay? Some thumbs up, okay? Share with your friends, networks, and students. Remember to put on the bell button for constant notification. I sign out at this moment. See you in my next class.